Hi guys. So today we're gonna be discussing about the SQL joins. And first thing first, we're gonna talk about what are joins. So joins are basically uh, when we have multiple tables. Joins are basically used to query data from multiple tables. And I'll give you an example. So now you can see that we have in this AdventureWorks 2012 database. I've got three queries here, so I'm gonna just run this query one by one. And so we have the select star from human resources employee table, and then we have, so if you actually go ahead and run this query, we have this whole bunch of columns. There's a business entity ID, there's national ID number, login ID, organizational number, organization node, and so on. And then we have the human resources employee department history as well, in which we have basically what this table is doing is basically recording the information of the employees who have basically worked on some department, but it's actually just storing the department IDs and the employee IDs in this table, and it's actually storing some additional information such as the start date of the employee and the end date of the employee as well. And it's also storing the shift as well of the employee, the information of shifts. So this data, this information, which basically is that an employee actually works for a department, is actually stored in three separate tables. And if we go ahead and run this run this query as well from the department table, we're gonna find information about the departments. So if I go ahead and run this query, all these queries together, I'll have a better we can have a better view that the first table was the employee table, which actually stored information about the employees. It's got the job title, it's got the login ID, it's got the business entity ID, which is the primary key of this table, and we got a bunch of different details. And then we have the department table here, which actually stores the information of the department, engineering, tool design, sales, and marketing, and so on. And then we have the employee department history table, which actually stores the information of the employee who works for the departments. Now, if you wanted to actually have this, now we have please note that right now we're actually running these queries separately. So what if we actually need to have one query which actually retrieves data of an employee actually who works for a department, for example, or we wanted to gather some information from the employee. We wanted to display, for example, the job title. We wanted to display something from here, and then the same thing associated from the first table. And we also wanted to display the department of that one, the name of the department of that, for example, this employee. And but that is actually stored in a different table. So we have to have, now this is where now we have to have a join of that table. This is where actually the join comes in. So we can actually have multiple tables query together. We can query multiple tables together in order to get or combine a result set actually on the basis of join. So I'm just gonna give an example, which is basically will be an easier example. So that is actually we'll be having two tables. I'm just gonna get rid of the second table. So what I'm gonna do is I'm gonna have a human resources job candidate tables. So what we're gonna find basically, I'm just gonna go ahead and run this queries. So what we're gonna find basically, what we're interested in is basically to make it easier. We're interested in now to get information of the job candidates and where information such as their job titles as well, and we wanted to find out which employees are, for example, job candidates. So what we can do is we can actually see it separately if we actually analyze that this table, the second one, which actually has the result set here. It's got the job candidate ID, which is the primary key of this table. Then we have the business entity ID, which is basically the foreign key, which is linked with the first table, which is the primary key here, and this is the foreign key. Then we have the resume of that person. Now this is a person actually. We have the resume of this person, and then we have the modified date. Now, for example, if you wanted to find out if any of the job candidates is basically an human resources and employee as well, so what we're going to do is basically I'm going to write a simple query which actually tells us how we can actually join the table on the basis of, and this is, by the way, will be an Equijoin, what I'm going to just write down. So I'm just interested in the job title from the first table. Let's see it here. Then we have, I also want to find out the login ID of the person. So login ID from the first table. And then I'm going to find out what else we've got. And we got the, for example, just want to find out the gender as well from the first table. Well, let's just skip the gender. Just the login ID and title is fine for now. So we're gonna just select this thing from the first table, and from the second table we're gonna have, for example, the resume. We're just gonna find out the resume from the second table, and then we're gonna specify both the name of both the table names. So first table first will be human resources. By the way, we can actually we can specify the first table, the second table first, doesn't matter right now because we're going to be doing an Equijoin. I'll tell you how that works. So human resources.employee table, I'm going to specify that one first. Let's just take it to the next line, so it'll be a better view. And let's just give it an alias as well for better referencing. So we're gonna be able to better reference the names, the column names. So human resources, and the second table would be the first table will be human resources.employee, and the second table will be human resources.job candidate, and this will be E2. Alright, and now I'm gonna give basically a condition here, and I'm gonna say where E1 dot business entity ID is equals to E2 dot business entity ID. Now we're basically joining, if you can actually understand here, that if I actually do this part, then we're gonna get all the rows of the columns, and that will be basically a Cartesian product. And we're gonna talk about that in a bit. That Cartesian product actually returns all possible combinations of the result set from the two tables. But right now what we're interested in is we're basically interested in an Equijoin, which actually results a set basically from the two tables, which are on the basis of some equality. So what we're interested in, basically we're interested on those job candidate IDs, basically on those job candidates who are also there in the human resources and employee table, or vice versa. So we're gonna go ahead and run this query, and now here we can just find there were only 2 employees who were actually they're registered in the employee table and who were job candidates as well. So the job titles of those employees were North American Sales Manager. We don't have a name here, but the login ID of that person was Stefan. We also have his resume here, which we can just click and it will open up as well. And then we have the quality assurance supervisor as well, and the login ID of this person is this, and it got the resume here. If we click on it, it will be like an XML thing. We're gonna talk about that in a separate video, but for now this was basically the result of that query that we just did for the Equijoin. Now we're gonna go back to our slides and we're gonna talk about the inner joins here. So what is an inner join basically? So as you can see the Venn diagram here, so the inner join is basically what we just talked about, that we have two tables right here and there. We got table A and table B, for example, and basically we're just interested in the data which actually is a which actually lies here in between the two tables. So what it actually does is it initiates with a Cartesian product. So what we're gonna have is basically, first of all, we're gonna have all the possible combinations of the two tables, and then we're gonna have a filter applied for rows matching. So we're gonna have first we're gonna have the Cartesian product. Then on the Cartesian product, we're gonna have a filter applied for rows matching based on a predicate logic. So now we're gonna have a hands-on for the Equijoin. Sorry, for the inner join. So in the SQL Server right here, we're just gonna change this query a little bit, and just to recall again, the inner join is a join that returns only rows from the join tables, and that will be from, in this case, from the employee and the job candidate tables, only where a certain condition is met. So where now we're gonna do is basically we're gonna change it a little bit, and we're gonna introduce the keyword join, the inner join basically, and then we're gonna specify the second table, and then we're gonna have to specify the on keyword as well. So this would be basically the syntax of inner join. So the result set here will be the same, but basically what happens is that in inner join, where because in this case where a certain condition is met and the human because there are only two candidates, which are basically stored in the human resources, the employee table in this case. So but actually in inner join, it's not because as it was in the Equijoin, it has to be on the basis of equality, whereas in inner join, it can be a predicate logic, and there can be a predicate logic, so that can be equals to, that can be greater than, that can be that can be less than, that can be greater than, that can be not equals to, it can be anything. So right now we're just having equals to logic, because we are actually finding out the business entity IDs are basically are the same in both the tables, so they are equals to. But if we're actually having a range of basically for example, a range of values for something, we can have less than equals to as well, less than or greater than, or less than equals to as well, or greater than equals to as well. So this is basically the concept that we're doing right now for inner joins. So that was the concept for inner join, and now let's move on to the other kind of join. Now let's talk about another kind of join, which is basically an outer join. So let's have a look here. So an outer join basically returns all rows from the first table, and it returns matching rows from the second table if you have any matching rows from the second table. So what actually happens in the outer joins is that one table's rows are basically preserved, and matches from other table is retrieved. So basically, let me give you an example. If if you wanted to return all customers, and for those customers who are basically their orders for the customers, so we wanted to return the if we wanted to have basically a data in which we wanted to have the information for the orders. So we wanted to display all the customers. Without matching orders, we'll actually display the null values for the order details. But for the basically who have actually placed the orders, we will view the orders as well with those customers who have basically placed the orders. So that will be basically an example of the outer join. This is basically it's used for. And basically in the outer joins, we have two kind of joins. We have a right outer join as well, in which we're going to actually return all the rows from the second table and only the matches with the first table. So this is a Venn diagram here. So it's going to return all the rows from the second table, which is basically the right side table, and only matches with the first table. And basically we're going to discuss this in the SQL Server. And then we have left outer join as well, basically which returns all rows from the first table, which is the left table, and only matches from the second table. So the basically all rows are returned, as you can see in the Venn diagram, from the first table, and only the matches will be returned from the second table. And we're gonna have this. We will be using the join keyword in the left outer join as well, just like in right outer join and the outer joins, and the on keyword as well. So let's move on to SQL Server, and we're gonna actually try the outer joins. So now we're gonna be practicing the outer joins, and now we have to understand that we have basically two tables. We're gonna take two tables from the production schema, which will be the first one will be the product table. Let's go ahead and run this query. So the product table's got the details of the product, but the product ID is a primary key, and the second table is basically the product review of that table. So I'm just gonna run both of these queries together in order to have a better view of that. So basically the products, we only got the 4 product reviews anyway in our schema, in our basically in our result set. And there were actually 4 reviewers who have actually reviewed the products. So what we actually can see here, that the reviewer name John Smith has the product ID this 709, which is basically the reviewed product, and then we have David, then we have Jill, then we have Laura. So what we're gonna do is basically we're gonna write a query in which we're gonna take an example of an outer join, and then we're gonna find out as of which products have been reviewed. So let's go ahead and write this query. So what I'm gonna do is I'm gonna write a select statement, and I'm interested in getting the. So we're gonna be having 2 names. So let's just specify. Let's just not use the aliases to avoid the confusion. So I'm gonna take the name from the first table of the product, which I'm interested in. So I'm getting this name from the first table of the product. Then we have and let's say then we can take the reviewer name as well from the second table. So the reviewer name from the second table, and let's just take the product number as well from the first table, so that we have a good picture. And then we're gonna specify the table name. So we're gonna be saying from production.product, and let's just call it P. And now what we're gonna do is now we have to specify if we're gonna be doing the right outer join or a left outer join. If it's not either of these, it will be a full outer join, as we talked about. But right now what we're gonna do is we will be doing the left outer join to understand this. So left outer join production, and I'm gonna specify the name of the table, which is the product review. and I'm gonna say it as PR. So just will be PR. Let's just bring it to the next line so that'll be good for visualization. And then I'm gonna specify the column name on which I'm gonna be putting the join. So that will be basically on the basis of the main join on the basis of equality which we're joining. So we're gonna be joining it on the product ID of the first table, which is the product ID, and the product ID of the product review table. And one more thing, since I'm doing the Equijoin, the left outer join, sorry. So I'm actually interested in getting the matching values of the other table. So we're gonna in the left outer join, we're gonna have all the values for the left table, which is in this case in the product table, and only the matching values for the right table, which is the product review table. So only the matching values for the product review table. And what I'm gonna do is basically I'm gonna say for the matching values, I'm gonna say I'm only interested in the reviewer names, which are like J. Since there are two J's, two reviewers starting from the name with the letter J. So let's put that as a clause. So I'm just gonna go ahead and run this query. And now you can see that for all the reviewers which are not actually starting from J, it is telling me, it is actually displaying me on null. And only the products which actually have a, and in this case, and it will be only a few, which basically starts from the reviewer names J and John, for example, it will be displaying the name here. So we have John Smith, and then we will be having one more, which would be somewhere down here, Jill. Here we go. So other than that, other than the ones starting from J, it will be actually displaying the null. So that was the example of the left outer join. In case of the right outer join, we have to do is it will be vice versa. So in the right outer join, it will be a matching value on the other side of the table, which will be basically in the right outer join, it will be displaying all the values from the right side of the table. So the right table will be actually displaying all the values, and only the matching values will be displayed on the other side. And in the full outer join, we would have no matching values. It will be actually displaying both. And so the full outer join would basically combine the result of the left and the right outer joins, and it will basically return all the matched or unmatched rows from the tables on both sides of the join clause. So now we're going to talk about the cross joins and the self joins. So what is a cross join? A cross join is basically also a Cartesian product. And a Cartesian product, as we already talked about, is basically it's going to return all the possible combinations of a result set. So if we have a table A and table B, and we don't have basically a condition for the join, it's what's going to basically do. It's going to give us a result set with both the values and all possible combinations of table A and table B. So basically, what's going to happen is it will combine each row from first table with each row from the second table. Now we have a self join, and what self join basically does, it actually compares rows to same tables with each other. So self join is basically a join with the same table. So for example, employees can be actually joined with another employee table. So we have two tables, and in which we can actually have a self join, and that will be the both the same tables. Let's have a look for better understanding in the SQL Server. So we have the SQL Server right here, and for better understanding, and actually in order to understand the self joins, we're going to actually create a new table, which will be a human resources dot call it an employee test. So employee test table will have the employee ID, first name, last name, and the manager ID. Let's go ahead and create this table. So this table has been created now. So now what I did was basically I inserted three values, a couple of values in the employee table. So we have, I'm just gonna go ahead and select star from the employee test. So if I select star from employee test here, I can actually see there are three values here. There's John Smith, who's basically the manager, so he's got null. The manager ID, he doesn't have a manager ID because he's a manager himself. And then we have two persons actually working under John Smith, which is Andrew, who's basically Andrew Anderson, who's got the manager ID 1. Basically, John Smith is his manager. And then we have Laura Norman, who's got John Smith as the manager as well. So right now we're gonna do a self join as well. We're gonna have we're gonna find out the employees who's basically got the manager IDs. So we're gonna just go ahead sorry, so that was basically a mistake here in the query, so we're gonna have to write the employee ID here. And let's just go ahead and run this query now. So we got only two people now who basically are working under a manager. So now we can see the result said that Andrew Anderson and Laura Norman are the employees who are working under a manager. So that is basically an example of a self-join query, which tells us that if we basically how we can actually have a join with the same table but with itself, and on the basis of some values, or basically we can have a join based on the logic. All right. So that was all for SQL joins tutorial today. I hope you liked it. Thanks for watching the video, and you have a great day. Thank you.